I'm Roshan Shaik. Uh, I, I lead the network automation team at Equinix. Um, my journey with software development has been around for like 20 years. I started initially working for Samsung, developing 3G network software, and then moved on to work at Sprint PCS. And then started at working at Cisco. I was initial architect on Nexus 1000V product line. And then I joined Silver Spring Networks, automating smart grid networking. So we had, close to 30 million IoT devices that we want to do auto provisioning, and all of the southbound protocols were, in-house and proprietary, and it was IPv6 mesh network, and we had to work very efficiently to do over-the-air provisioning for all those devices. From there, I joined Equinix to do service automation for Equinix. I'll go over what we do at Equinix and then my journey of automating Equinix services. Equinix is a world leader in interconnection platform. We operate close to 200 plus data centers all across the world. We have about 10,000 customer base, and then over 52 markets, and about 4 nines of service reliability. That means if we are down less than 4 minutes in a year, then we have to pay some of the customers. And let's move to the next one. So we are across all 5 continents, 24 countries, major 52 metro areas, and about close to 230 cross connects. I'll go over what cross connects are. And our goal is to reach everywhere, interconnect our customers with their customers, as well as cloud providers and ecosystems, and then integrate everything, provide integral services through our data centers so our customers can accelerate their digital business through our technology and interconnect platform. So these are high-level services that we offer, and they are umbrella services. Within each service, I mean, there are many, many variants of services in each region. So Cloud Exchange is the new service that I started off automating 4.5 years ago at Equinix. I'll go a little bit deeper about what that service is, how we automated that. And the next one is the Cross Connect and Metro Connect. So these are like our customers in a big metro. They're connected to one data center, and then they want to reach to a partner in another data center or themselves in another data center. Then we provide cross-connect services to them. And some of them as well are in the Metro Connect. So that means we can either provide low-speed Metro Connect or high-speed Metro Connect, which are like close to 100 gig services. And then we have Equinix Connect service, which is a transit service for customers who are inside our data center. They want to go out of the network or connect to internet service providers. And that is the Equinix Connect service. And then the bread and butter is our Equinix Internet Exchange. So where our customers, they join a public peering community, and then anybody who wants to share prefixes or routes, they can do so within that Internet Exchange community. So Cloud Exchange. So I joined Equinix about 4.5 years ago, and I was the only developer, and we wanted to automate Cloud Exchange, and we want to do it in 6 weeks. And then we had one more developer who's like Java database, and he wants to do northbound side of the automation. And we looked at various tools, WebNMS, Zoho, um, Blue Planet at the time, and few other services. And our goal was to expose our services as API to the portal team or the northbound side. So wherein our customer can go to a self-service portal and input some service parameters, and they hit the submit button. We want the service to be automatically activated on our network within a few minutes. And prior to this, we had legacy services like Internet Exchange, Equinix Connect, and Metro Connect services. And typically, they used to run about 3 days as of SLA to activate those services. I mean, once the port is purchased, there are a few other things that needs to be done. So then we need to reduce it down to 5 minutes. That means we have to create services automatically, no hands, and everything has to be done through APIs. So we looked at TailF at that point, and then we had Larry and a few other folks come in and then create some sample services for us. And since I was the only developer, I was also asking them, hey, let's do this service that we wanted to deliver. So actually, this is the service. And then let's do it as a POC. And I had only 6 weeks. I didn't tell them I had 6 weeks. And then we did a POC with them. And we automated layer 2 service. And then it took us like about 1 month to do both port and layer 2 service. And then after 2 weeks, we asked, let's go live with production. And then we started off like that. We went to production, and then within a few weeks, we had customers accessing, and everything went fine afterwards. Now, after 4.5 years of journey, we have about, we started off with layer 2 service, 10,000 services activated through NSO for layer 2. And then we also moved on to automating some brownfield services like Internet Exchange, which has been around for about as long as the company has been there for 20 years. We just started automated provisioning for Internet Exchange live a few months ago. And we have some services already being activated through that service. So overall, about 20,000 services that were activated through the portal using the software. So the Cloud Exchange service, in essence, is basically allowing customers to access cloud providers using our private network without going through the internet. So we provide MPLS network to within our data centers, and any customers who is within our data center can then access these cloud services, high speed, low latency, and private, secure access to the cloud. AWS, Azure, Google, and we have about 100 plus cloud providers now on our network. Going over here, so we started off with initially layer 2 service, and then we modeled layer 3 on top of it, and then layer 3 we wanted to do a more componentized way, so we can sell a routing instance to a customer, and then the customer can buy a routing instance, and then he can say, hey, I want to connect to Google, and Google says to us that we don't want to flood our network with customer prefixes. Equinix, why don't you do NATing, and we trust your NATed IP addresses. And so we had to do a service chaining with NAT service models. And there are some other customers like Salesforce who are more on the public SaaS network, public SaaS providers. And for them, they want to take the customer routes as is. So for those type of customers, we don't offer NAT services. And then there are some customers within Equinix that says, we want to NAT ourselves in-house, and then we give you your routes, and we then take those routes and publish directly to the customers, for customers who don't have public IP address space. Our goals when we started were, of course, provide API access to our BSS systems. And then we also wanted to have a service validation. That means when the service is activated, whether the service is working or not. For a BGP service, we could go and look at the routing table and see whether we are learning prefixes or not. For layer 2 service, we could go and check whether we are learning MAC addresses, and also check if the bridge domain or VPLS is up or not. So provide some input into the network for our operations team to troubleshoot issues that they are facing with the customers. And at the same time, we also want to future-proof our architecture for creating new services. One of those services I'll cover later is providing an NFV service to our customers. So we are also using NSO, NFVO, and ESC controller to create this brand new service. I'll go over a little bit later on that. So this is the architecture or component view of network provisioning systems at Equinix. And so we started off with Cloud Exchange services. We have about 8 different services within that umbrella. And then the brownfield service for IX services. And then Equinix Connect, we are automating in transition right now. And then we're also looking at providing the Metro Connect, high-speed Metro Connect services through NSO. And the new service that I was talking about is the NFV services. So we have looked at Red Hat and few other vendors, OpenStack vendors, to come in and then do a proof of concept for us as a NFV infrastructure. And then we also looked at Cisco, and the same use case that we had for Cloud Exchange to have an API into the NFVI, as well as create those services within a time frame that we want our customers will be happy with. So that same model, again, fit well with the NFVO package and ESC controllers, and then UCS as the NFVI infrastructure. This is right now in beta mode, so we'll onboard new VNFs. Right now we have CSR 1000V Juniper VNFs, and we're looking at adding firewall, Palo Alto, Fortinet, or some DDoS, as well as SD-WAN as services onto the NFV platform. So another important thing for us is to have auditing and logging capabilities. We are going through a FedRAMP certification. So basically what it allows us is to do business with US government. So any entity that works with US government has to go through this FedRAMP certification. So we had a third-party vendor come in and then do a audit on all of our systems, BSS, OSS, network, how do you touch the network, who touches the network, who has permissions, and all such. And they were quite happy to learn that we were using NSO and secured NSO through NACM and NACM rules. So nobody can access except few user groups through the API to NSO. And of course, it's all SSL enabled, so nobody in the middle can also interfere with those services. And also want to see the logging and playback features. The playback feature has been quite useful. For example, redeploy, right? Sometimes we have operations team. We have a global operations team, and they sometimes log in to the routers and then accidentally delete the service. And they'll come and say, hey, NSO is not working, it's deleting services automatically. And then we go and check and do a playback. We say, hey, the service is in the CDB, whereas it's now deleted on the device. We go through some logs and then find out somebody had manually tinkered with the service. And then we just issue a redeploy command, and it redeploys to the original customer configuration on the routers. Apart from that, so we're also looking at automating other brownfield services. So EC and IX, they'll be coming pretty soon. We are right now using a couple of netconf nets and REST API or AOS Arista net. We are also looking at a few other nets for VNF vendors. We're going to work with Cisco to enable those nets, and then we can offer those easy services configured and serviced through NSO. This is our deployment model as of now. So we have an interconnection portal, and then there's a BSS orchestrator at the business layer. They deal with billing and procuring various other services or any internal orchestration that they need to do. And then we have network provisioning or NSO REST API exposed to those business orchestration. And they use the REST calls to come into NSO. And we have deployed 4 NSOs right now, in all of them in US region, 1 in Silicon Valley and 2 in Chicago for disaster recovery. So we have 1 master, 3 backups, and something to happen to SV data center, then we switch over to Chicago data center. So this has helped us in deploying or modifying our software or the packages without bringing down the portal or without affecting the customers who are trying to create services. So when we try to upgrade our package, then we just mark one of the backups as the master, and then go upgrade the packages on other NSO instances. We are also looking into going regional with NSOs. So we may go with 2 or 4 in Americas, and then 2 or 4 in EMEA, and 2 or 4 in APAC. This may be needed for optical services, where we want the orchestration to be close to where the devices are. We're also looking at scaling, some scaling issues. Some services like IX services are independent of other Cloud Exchange services. And right now, when we have one NSO configuring these services, then we want to have parallelism between those services, so one doesn't affect the other, so the SLAs can be met. So coming from software background myself, so once we deliver the first service, the immediate thing I did was to hire a QA developer. Not a software developer, but a QA developer to test our services. So we have right now we have a dedicated test lab with actual devices, and we have automated about 800 various REST APIs into those test cases. And so anytime when we need to upgrade the package or change our network architecture, so we also change our templates, add additional devices, offer new services, then we kickstart this test framework, and then it runs a couple of days, and then we get a green signal from the QA department that all the services and tests went well. And then we also automated deploying the services into the production networks using Ansible. So we are using Robo framework for creating test cases and for continuous build Jenkins. We can take a new NSO build as well, and then deploy the NSO, deploy our packages, and then start our testing. The whole thing could be done in a couple of days, and within a couple of days, we can certify whether a brand new NSO build is good for us, or where some test cases are failing. Then we reach out to a NSO team to help us in fix those issues well ahead of time before we go into production. We use Jira. We also do agile development for end-to-end service deployment. So we have teams from portal, databases, and operations team, and the network architecture team, and then provisioning team, all as part of the agile team. And they can define user stories. We have product owners, and then define what service changes we want to offer, what new services we want to offer, and then cascade those into provisioning requirement for NSO. So this is the whole CI/CD cycle that we've been following at Equinix. I think that's my last slide, since I'm standing just before lunch. So any questions? I know I ran through a lot of our experience quickly, so if you have any questions, I'll be happy to ask.
Hi. So when you developed and deployed your Cloud Exchange services somehow within inside of 6 weeks, did that include service discovery of existing services, or were those customers just not eligible to make changes through NSO day one?
So luckily for us, it was a green service, green field. So we didn't have any existing customers. So 6 weeks was to launch in few metros initially. And then we had our cloud providers, AWS and Azure, as initial cloud providers at the time. And it was only a layer 2 service. So, and then we only launched in few metros, and then we replicated that deployment in other metros.
So then the later services then, were any of those brownfields, and then did you have to do service discovery for those?
So for Internet Exchange, yes. So there is it's a brownfield, and then we have to create some of those services ourselves into NSO. So NSO is aware of those services.
And that was a manual process?
That was a manual process,
okay.
Yes. So we had to take in the existing service parameters and then do a no networking in NSO. So it doesn't go and change the existing service, but it is stored in the CDB.
Okay, and do you have, so the customer up at the top layer of this, right, who has no knowledge of the underlying systems, do they sometimes have issues where, because you talk about operators sometimes accidentally deleting services and things like that, so do they have issues where things go out of sync and then they're unable to commit their changes, and does it just say, oops, something bad happened, or, how does that?
Yes, so when we initially started this, we noticed that our operations team has constantly been updating the devices and then NSO going out of sync. So what we did is, we created a portal for operations team to go in and do a device sync themselves whenever they do manual changes, and that internally calls NSO API to do a check sync and then do a sync from operation from the device. So having implemented this process, the operations team now know that whenever they go and do any manual changes, they'll have to go and and do a sync operation using that portal. Otherwise, our request from the customer, they will fail because of out of sync.
Well, so that'll handle device sync issues, but what about service sync issues? If something happens with the service, do your operators know to go back and change the service parameters of a service, or?
So we do have some of those challenges. Like, for example, when you do end-to-end automation for AWS, which is a layer 2 service, initially a customer has to go to AWS, and then they have to input a VLAN, and then come and input the VLAN through our portal. So many times they change the VLAN, and AWS don't change the VLAN on our side, and then they say the traffic is not flowing. So for such cases, we have implemented something where in the portal itself they can change some of the VLAN, or operation person can manually go and change the VLAN on the router, and then they will either notify us to go and change the VLAN within our service parameters. We are also looking at editing capabilities, which is coming pretty soon, wherein we can edit any of the service parameters through an API way. Even though NSO supports it, our ecosystem within Equinix, like the portal, BSS, they don't have editing service capabilities yet.
Okay, thanks.
Yes.
Hi there, KJ Rosvik from the BU NSO product manager.
Okay.
So we have a customer, a large bank that's currently working on integrating with Equinix.
Okay.
And we are creating an ad for that. And just struck me that wouldn't it make more sense if Equinix provided a netconfig interface so others could integrate directly from NSO to your services?
Yes, so we've been thinking through that for quite a while to enable east-west communication with other providers on the networks. Right now, the API that we expose through network provisioning system, they are private API internal to Equinix. The same API with few other tweaks are exposed as public APIs to our customer. And there is also a developer portal within Equinix wherein customers of Equinix can exercise our APIs, the public APIs, the internally called the network API that we have. Like here, the Equinix portals. So the same API are as exposed to our customers. So those APIs they can use, and probably could create a net for those APIs. And any customer of Equinix, while creating Cloud Exchange, Internet Exchange services, they can use those API to trigger. We are using those APIs ourselves from the NFV service. So we are creating a virtual router on behalf of the customer inside our network. And then using that virtual router, they can trigger Cloud Exchange, IX, or EC services using the API. So we have existing APIs. And in the future, we will also look into enabling east-west communication across various networks.
Yes, I have a question. How do you handle, if you handle now, or how do you plan to handle topology changes, like planned maintenances, which inflict changes to the way the services are delivered, like if you have to redeploy the service on a different port? So how do you do that automatically, manually? How your operational staff is keeping NSO in sync with the changing topology?
Yes. So I haven't mentioned here is we do have a topology service implemented in NSO for each of these networks, and we know which ones are leaf, which ones are core switches, as well as which one have different capabilities. For example, some devices have NAT capabilities, some devices don't, and so we have that topology information implemented within NSO. And when a service needs to be created, we do some orchestration to see what topology and what devices need to be modified for those services. So coming back to your deployment question, So our networks are a different network in each metro. Different meaning they're not interconnected. So when we are doing an upgrade, we are upgrading on a metro to metro or within a regional basis. So only those devices are either disconnected from NSO during the maintenance operation. So no services can be created on those devices. And then we reconnect them back after the maintenance is performed. So that's the process that we have implemented.
Okay, but if something changes on the topology, let's say the device where the service is deployed changes, you change it to a different device, or you upgrade the line card. How do you keep the services in sync with this?
Yes, so that's a valid question. I mean, we haven't had that happen to us yet, but definitely, like if you have to do an RMA of a device, then we have CDB, which has all of those services, and then we'll probably, manipulate them and then trigger API to go redeploy all those services onto a new device. Or a new line card, depending on the case. But we haven't had that happen yet, but we have a plan of how we can recreate these services. We did have like some corner cases, like customers of us, like AWS, initially was using Equinix ports, and then we wanted to use or give a separate set of ports for AWS. And we need to now migrate the Z side of the services on those ports to a new port. And what we did is all those APIs are now enabled through NSO. Then we have a BSS system, and they will use our APIs to change the Z side service parameter and then redeploy the service.
Okay, thank you.
Yeah, I had a quick question.
Sure.
So it says optical services there.
Yes.
What? How do you? Or I mean, so for me, I used to more run networks rather than write software. So for me, Equinix and interconnects was always about physical cross connects, between operators and optical services. That sort of sounds like that to me. But what is that? Is that something you automate?
So these are basically two types of optical service, right? The cross connect as well as metro connect. And the cross connect, we are now, even though it's a physical L1 connection, we are now trying to take it to a virtual level, wherein we have a new architecture where you can go and provision the optical bandwidth as per the customer requirements instead of pre-provisioning the bandwidth. So that's what we are going to start deploying. We are right now in the proof of concept mode to work with various optical vendors to create the services.
But is that like a photonic cross connect or something? Is that one of the services?
Yes, but that will go through a photonic controller, and then we'll have a net created for that photonic controller in NSO to trigger that service through a customer portal.
Okay, thank you.
Yes, sure. Okay, so I guess we can have lunch.
Thank you, Roshan. Very good.